Understanding Physics, and this is Assessed Practical number 5, and it's about resistivity. And we're not going to find the resistivity of a wire, we're going to find the resistivity of a material. Yes, constantan. This will be the equipment and basically how it's set up. So a variable DC power supply, yes. So like that, turn a knob, change the voltage, and a voltmeter. This has got a built-in voltmeter, this one. If it hasn't, then you need a voltmeter across it to read the voltage, an ammeter to read the current. Now, what I give my students is I get a meter ruler and a piece of wire, nice and straight, attached to the ruler. Okay. And it just saves a lot of fiddly messing about, and so you've got about a meter of wire nice and straight attached to the ruler, fixed at one end, and then the other end you've got like a floating lead which is a crocodile clip. And the idea is what we're going to do is change the length of the wire, and you do that by attaching the crocodile clip in different places. And I recommend from about 30 centimeters up to, you won't manage a full meter, but maybe 90 centimeters, different lengths of wire. And we're going to measure the voltage and we're going to measure the current. And you'll need a micrometer as well to measure the diameter of the wire. Yes, in 3 different places. Digital micrometer makes life a lot easier, but any kind of micrometer. Constantan, apparently that's got good mechanical properties, as in it fatigue resistance apparently, and good thermal properties. So if it gets a little bit hot, its resistance doesn't change very much. About 26 SWG, which is about a diameter of 0.5 millimeter. Maybe a little bit thicker, it's up to you, but that would do, 26 SWG. Constantan. An alloy of nickel and copper, apparently. So what we're going to do is measure the resistance of different lengths of wire. So I've got in my table here from 50 centimeters up to about 90 centimeters. Now, what you could do is keep the voltage the same and change the current. Yeah, when obviously as the wire gets longer, the current will be smaller. Or you could keep the current the same and change the voltage so that the current is the same. In other words, your current is the controlled variable. And that's actually a better way of doing it, because then if you didn't, then the shorter wire would have more current in it and it would get hotter, and so its temperature would be different. Yes, so it's better to keep the current the same and then change the voltage so that the current is the same. Yeah. Constantan is an alloy which has good mechanical and thermal properties. Already said that. I've used to do it with nichrome, was another one, nickel and chromium. Measure the diameter of the wire in 3 different places with a micrometer and average. And as I said, it's better to keep the current the same because then the temperature of the wire will be the same for different lengths. Then we plot a graph of resistance against length, and if you look, R equals rho L over A, so resistance is rho over A times L, so the gradient will be rho over A. So you get the gradient, multiply it by the cross-sectional area, and that is your resistivity. Uncertainties now, quite a few. The resolution of the micrometer, it's about 100th of a millimeter. So for 50 centimeters, that's going to be about 2%. So the area, because it's pi r squared, will be about 4%. The voltage and current depends on what meters you use. The length of the wire, plus or minus a millimeter, so that's about 2%. Research a value for the resistivity with a reference, and then see if the value that you get falls within the bounds of your uncertainties. So if you get blah blah plus or minus such and such, you know, does that match the reference off Tinternet? These are the bits, pretty straightforward. So taking measurements, blah blah blah, using digital instruments, using a micrometer, building a circuit, pretty straightforward.